Hi students, how are you? I hope all of you are fine and I wish that. Okay. In this session, we are going to discuss about some practice questions. Okay. In the earlier videos, you have seen all the videos as per the textbook, exercises and examples. Okay. Now we are going to do some practice exercises until the topic what we have seen, mainly on the fundamental theorem of arithmetic. Okay. There are some 15 practice questions given in your learning platform vadivel-vadyar.com. Okay, you can watch that and make use of it. Okay, let's start. Okay, you can read the question now. Can two numbers have 15 as their HCF and 175 as their LCM? Give reasons. Okay, see, this is purely related to a different concept. Okay, if you understand that concept, it will be easy for you. Okay, always the LCM is divisible by HCF. Okay, for example, you can take some two numbers 10 and 150. Okay, we can prime factorize, we can find out the HCF and LCM, and let us check the HCF is dividing the LCM or not. Okay, so if you prime factorize here, 2 into 5 will be the factors of 10, and for 150, 2, 75, 5, 25, again 5 times. Okay, so 2 into 5 power 3. Okay, now you can see the HCF is take all factors with the lowest power, so 2 into 5, and for LCM take all the factors because 2 and 5 both are common for both numbers. Okay, so 2 into 5, now 2 power 1, 5 power 3. Okay, so 2 power 5 here, HCF is equal to 10 and LCM is equal to 2 into 5 cube 125 is equal to 250. Okay, see, 250 is divisible by 10. 250 by 10 is equal to 25. Okay, so we confirmed here LCM is divisible by the HCF. Okay, now coming to the question, check here. The HCF is 15 as their HCF and 175 as their LCM. Let us make a division. 175 is the LCM divided by the HCF by HCF is equal to 15. Okay, check, 15 will not divide 175. Okay, 11 15s are 165 and 12 15s are 180. Okay, so 175 is not divisible by 15, hence the given two numbers 15 and 175 cannot be the LCM and HCF of any given numbers. Okay, so you have to simply reply for answer for this question in a conceptual way. Okay, now we can write the answer. Okay, always LCM is divisible by HCF. Okay, as the given HCF 15 cannot divide LCM 175, the given LCM 175 and HCF 15 cannot be for any given numbers. That's all. Okay, so you should apply the concept. LCM divided by HCF is a integer. You will always get an integer for this. Okay, but if the HCF is not dividing the LCM, given those two numbers cannot be the LCM and HCF of any given two numbers. We have to conclude like that. Okay, students, let us see the second practice question. Okay, explain whether 3 into 12 into 101 plus 4 is a prime number or composite number, right? As we have seen in the earlier videos, when you are asked to conclude a given number is a prime number or composite number, you have to find out the number of factors for the given number. Okay, as you know well, prime numbers are having two factors, number 1, and the second factor is the number itself, right? So prime numbers are having two factors. If you exclude one, prime numbers are having only one factor, and that factor is that number itself. Okay, when you prime factorize this number, if you are getting only one factor, then that number is the prime number. Okay, if you are getting more than one factor, you can conclude the given number is a composite number. Okay, now let us prime factorize this given number. Okay, right. So given number is 3 into 12 into 101 plus 4. Okay, you can see, consider this plus. Before the plus, 3 multiplications are there, right? So all these 3 together you have to consider as one number, and 4 is another number. Okay, so we can write, you can see here 4 is available here and 12 is available here. Okay, we can take this 4 out, so we can write 4 into 3 into this 12 becomes 3 because 4 has come out, and multiplication with 101 plus 1 because 4 has become 1. Okay, now 4 into, if you multiply these three numbers, 3 into 3, 9, 9 into 101 plus 1. Okay, and again 4 into 9 into 101 is equal to 909 plus 1. Okay, so we can write 4 into 910, which is equal to 4 zeros are 0, 4 times 1 4 and 36. So the given number is 3640. The given number 3 into 12 into 101 plus 4 is equal to 3640. Okay, now we are going to prime factorize this 3640 and find out the number of factors. Okay, so take the number 3640 to 18 times 36, 20 times 40. Okay, and again 2, 9 twos are 18 and 10 twos are 20, 910. So now the last digit is 0, so we take 5. Okay, so 1 5 is 5, 41, 8 5s are 40, balance 10 2 times. Okay, so 182. Now again take the factor 2, 91. Okay, 91 is divisible by 7. Okay, so 7 into 13 is equal to 91. Okay, so we can write the factors 2, 2, 2, 3 times. So 2 power 3 into 5 into 13. Okay, you can see more than one factor available, right? 1, 2, 3 factors are available. So we can conclude the given number is a composite number. Okay, you can write here 3640 is equal to 2 power 3 into 5 into 13. Okay, and your answer should be, as the given number is having more than one factor excluding 1, it is a composite number. Okay, so we can write as the given number is having more than one factor within bracket you have to write excluding 1. Excluding the number 1, it is a composite number. Clear, students? So, to conclude, a given number is a prime number or a composite number. We have to check the number of factors and decide it's a prime number or composite number. Okay, and make sure you are being familiar with the prime numbers. Okay, watch roll-up videos, and there is a video given the prime numbers below 200. Okay, watch that video, and there is an attachment. You can download that PDF file and take a print and keep it with you for your reference, so that at least you will be familiar with the prime numbers below 200. Okay, and also you have to be familiar with the divisibility rules. There are 2 videos given on the divisibility rules. Scroll up videos, check it. You can see 2 videos. Divisibility rules until 11, there is a video. Next to that, there is a video on the divisibility rules for 13, 17, 19 and 23. Okay, watch those videos and make use of it. And for the divisibility rules also, there are 2 PDF files attached with that videos. Okay, download it, take a print and keep it with you always, so that you will be able to do very quickly prime factorization problems. Okay, now let us see the third question. Okay, 3 numbers are in the ratio 2:5:7 and their LCM is 490. Okay, find the square root of the largest number. Okay, so what is asked in the question? There is a ratio given between 3 numbers and then their LCM is given. Okay, by using this ratio and the LCM, we are going to find those 3 numbers. Okay, and then find out which number is the biggest number in these 3 numbers, and then you have to take the square root. Okay, find the square root of the largest number. Okay, right. Now let us try to solve this question. Okay, now 2:5:7 is given. Let us take x be the ratio. Let us keep the ratio as x. Let x be the ratio. Then given numbers are 2x, 5x and 7x. Right? Right? Let's consider the ratio as x, and then the numbers will become 2x, 5x and 3x. Okay. Now the LCM is given here 490. Okay. So the LCM of these 3 numbers is equal to 490. Okay. Now how will you find out the LCM of these 3 numbers? Okay. 2x is there, 5x is there, 7x is there. Right? There is no integers given. So how will you find out? Okay. Now take an example of the numbers 9, 13 and 17. Okay. Earlier we have seen a question in your scroll up video. Okay. There is no common factor for these 3 numbers. Okay. So we have taken HCF as 1. Do you remember this question? The numbers I have changed. Okay. But the methodology, concept is same. Okay. LCM is equal to the multiplication of all these 3 numbers. 9 into 13 into 17. Okay. So you multiply this. Okay. And find out what the answer is coming. If you multiply this, the answer will be 1729. Okay. So 1729 will be the LCM for these 3 numbers. Okay. Now the same methodology, same concept we are going to apply here. Okay. So the multiplication of 2x, 5x and 7x is equal to the LCM 490. Okay. So LCM is equal to 2x into 5x into 7x. Okay, now which is equal to 450. Okay, now let us take this x out. 2 into 5 into 7 is equal to 450. Okay, so 2 5s are 10, 10 7s are 70. So 70x is equal to 450 and x is equal to 450 divided by 70. 0 0 1 7 is 7. Sorry, 490. Sorry, 490. So 7 times, okay, 49. So x is equal to 7. Right? Now we found the x. Okay. Now we can find 2x, 5x and 7x. Right? So the numbers are 2x is equal to 2 into 7, which is equal to 14, and 5x is equal to 5 into 7, which is equal to 35, and 7x is equal to 7 into 7, which is equal to 49. Okay, so we found the numbers and check among these three numbers which is the biggest number, largest number. 49. Okay, so the square root of 49, the square root of largest number 49 is equal to, square root of 49 is equal to 7. That's it, students. Okay, now what we have seen in this class as a summary, okay, ratio is given and their LCM is given. Okay, you are keeping the ratio as x. Okay, and then the numbers will be 2x, 5x and 7x. Okay, and multiplication of these three numbers is the LCM. Okay, we applied here and we found out the x value as 7. After that we find 2x, 5x and 7x. So we found the three numbers 14, 35 and 49, and we have taken the largest number and find out the square root. Okay, students, clear? Let's see the next question, number 4. Okay, the ratio between the LCM and HCF of 5, 15, 20 is what? Okay, see, it's a direct question. There's no trick. It's not a tricky, very direct question. Okay, ratio we have to find the LCM and HCF of 5, 15 and 20 and then find their ratio. Okay, let's start prime factorizing 5, 15 and 20. Okay, as you know well, 5, the factor is only 5, right? And 15, you know well, 3 into 5, right? And for 20, you can prime factorize 2 times 10 and 2 times 5. So we can write 20 is equal to 2 power 2 into 5, right? Now LCM is equal to, take all the factors 5, 3 and 2, 5 into 3 into 2, take the highest power here, only 2 power 2, right? So 2 power 2, which is equal to 5 3s are 15 into 4 is equal to 60. Okay, now let's find the HCF. HCF, take the common factors, only 5. So HCF is equal to 5. So what is asked in the question? Ratio between LCM and HCF. So LCM is coming first. Okay, so we can write LCM is to HCF is equal to 60 is to 5. You can simplify that, 12 is to 1. Okay, that is the answer. Okay, so it's a direct question. You can straight away prime factorize the given numbers and then find the LCM and HCF and find their ratio. That's it. Now we will see the question number 5. Okay, a warehouse has 1764 kgs of rice and 2350 52 kgs of sugar. Okay, the manager wants to pack them into equal weight sacks without leftover. What's the greatest weight of each sack can hold? This is the question. Okay, in a warehouse, two types of products are in stock. Okay, 1764 kgs of rice and 2352 kgs of sugar. Okay, now both he is going to pack. Every bag will contain both rice and sugar. Okay, if he mix and pack into many bags, okay, what is the greatest weight each sack can hold? This is the question. Okay, so here you should be able to identify whether you have to find HCF or LCM. Okay, in the scroll down videos I have given you a clue for finding LCM, right? When two incidents are happening at a regular interval, for example, two bells are ringing together and two people are running around a sports field, okay, like that. Okay, one person will be running at 15 minutes interval, another one will be running at 30 minutes interval, right? Two bells are ringing, one is ringing at 15 minutes interval and another one is ringing at 30 minutes interval, like that. Okay, when two incidents are happening together, you have to find LCM. Okay, now here you can see a big quantity is divided into small quantities and packed into different sacks, right? Always you can see HCF is the smaller than the given two numbers. Okay, the name is highest common factor, but it is a factor. Factor is always small, right? It's a divisor. Divisor will always be smaller, right? So when a big quantity is divided into small quantities, you have to find out HCF. Okay, this is the clue. When a two big quantities are mixed together and divided into small quantities, you have to find out HCF. Okay, now you can start the question with the greatest weight each sack can hold is equal to the HCF of 1764 and 2352. Okay, so we can start the answer. The greatest weight each sack can hold is equal to the HCF of 1764 and 2352. Okay, now we have to prime factorize 1764 and 2352 and find out the HCF. Okay, so let's take 1764 2, 8 times 2, 1 balance 16, 8 times and 2 times 2 is 4, 882, and again 2, 4 2s are 8, 4 2s are 8, 1 2 is 1, 441. Okay, now 441 can be divided by 4 plus 4 plus 1, 9. So 9 is divisible by 3. So 3 will divide 441, 1 times 14, 4 times 21, 7 times 147. Okay, 147 can be divisible by 4 plus 1 plus 7, 8 plus 7, 15. So 15 is divisible by 3. Okay, so again 3, 4 times 12, 27, 9 times. Okay, again 7, 7 sevens are 49. So 1764 is equal to 1, 2, 2 power 2, 3 2 times. So 3 power 2, 7 2 times, 7 power 2. So 2 power 2 into 3 power 2 into 7 power 2. Okay, now let us prime factorize 2 3 5 2. 2 3 5 2 2 11 times, 15 7 times, and 12 6 times, 1176. Again, take 2. 5 2s are 10, balance 17. 8 2s are 16, balance 1, 16. Again, 8. Again, take 2. Okay, so 2 2s are 4, 9 2s are 18, 4 2s are 294 is coming. Okay, right. Now, again, take 2, 1, 4, 7. Okay, now 4 plus 1 plus 7, 15. 5 plus 7 is equal to 12. No, 7 will divide this. Okay, 7, 2, 7, 1, 7. And again, 7 3 times. Okay, so now 1, 2, 3, 4. 4 times 2. So 2352 is equal to 2 power 4 into 7 power 2 into 3. Okay, now we have prime factorized. Now we are going to find the HCF. Okay, so take only the common factors. 2 is here, 2 is here. So take the number 2, and 3 is here, 3 is here. Take number 3 also, and then 7 is here, 7 is also here. So 2 into 3 into 7. And now let us take the power. You have to take the lowest power. 2 power 2, here 2 power 4. So 2 power 2 is the lowest power. Take the power 2 for 2, and 3 power 2 is here, 3 power 1 is here. So the lowest power for 3 is 1, and 7 power 2 is here, 7 power 2 is here. So the lowest power is 2. Okay, now we have found the factors. Okay, now 2 power 2 is equal to 4 into 3 into 7 power 2 is equal to 49. So 4 into 3 is 12. 12 into 49 is equal to 490 plus 98, which will be 588. Okay, so the HCF is 588. Okay, so the answer is the greatest weight each sack can hold is 588 kgs. You can write here, hence the greatest weight each sack can hold is 588 kgs. That's all, students. Okay, so instead of concentrating on the solution, you should concentrate on the concepts. Okay, on which concept or by which concept you are going to find solution for every question. Okay, so learning the concepts only will help you. Okay, that's all, students. Thank you very much. Stay focused, stay tuned, stay confident. Let's march towards our mission of target 100. Thank you, students. See you in the forthcoming lessons. Bye bye.